It is a method which is a subset of all the methods, which is known as methodology. So someone may say, I want to maybe use simple random sampling method to collect my data. For instance, another person will say, no, let us stratify the population to use the stratified sampling method to collect our data. Is that clear? That now boils down to a specific tool, method of what? Data collection. Do you understand that? But it is not the methodology. Methodology includes it, and at the same time includes every other things that are involved in the research work. So that is the difference between two of them, and it's very important because oftentimes researchers tend to maybe use two of them interchangeably, but they are not the same and cannot be used interchangeably. Is that clear? Having said that, we will begin to drive closer to some other aspects of our workshop that are very important, especially as it concerns every research work. I have told us that in every research, especially empirical research, as you people do, there is need for what? Data. It may not be about human beings, because I know those people in the medical sciences over there at Soka, that's something I know they do a lot. That's why something that is not supposed to be a means of an economic gain has become a means of livelihood for some people. You know that in rearing of albino rats, there are some people that are using it to make livelihood, and it is of no use to human beings. But I don't know. There are some people, there are some labs, each time I'm passing, I will see maybe 30, 50 of them albino rats here and there. People are busy training them, rearing them, and they are making a lot of money from such. So, if one is carrying out a research that requires getting data from albino rats, it is still getting data from individuals. Is that clear? If it is one that requires getting data from human beings, it is the same thing. I hope it's clear. If someone is interested in carrying out a research about on lizards, and he or she needs to maybe get hold of a number of lizards for the person to be able to generate data, that becomes what? The individuals involved in his or her own research. Someone may be interested in looking at maybe the incidence of some cars. For instance, I want to give a very simple something. One would begin to wonder, of all the vehicles that are in Nigeria, which one is has the highest frequency? Do you understand that? I don't know if you have thought about something like that. And maybe you stand at the corner of the road and you are resting and you are checking the number of vehicles. This one, Toyota has passed. Another Toyota has passed. Another Toyota has passed. Mazda has passed. And Honda has passed. Toyota again. Toyota again. Toyota again. Lexus. Toyota again. Mazda. Do you understand that? What are you trying to check? You are looking at the rate of or the frequency of various brands of or makes of cars. Do you understand? She's there. That person will come to a conclusion that Toyota is more in use in this city than every other car. Do you understand that? That is a very simple research work. And that research work started by taking a rest somewhere and is concluded somewhere at the same time. But it's a research work because it's born out of something that you did. If someone asks you, you'll be able to take that of all the, within these 30 minutes I was here, of all the 100 cars that passed by this road, that 62 of them are what? Toyota. Why only maybe 10 of them are Mercedes, and so on and so forth. With that, the person comes to the conclusion by making a generalization. The person has used this data that he or she obtained from only 100 vehicles. The person can now generalize that in the whole of this locality, that about 62% of all the vehicles are Toyota make. Do you understand? Can you see very simple and wonderful research somebody has embarked upon? And the person can go anywhere and begin to say it. Maybe somebody can do it here in UNEC, and at the end it will come up that there at UNEC that 62% of all the vehicles are Toyota. And the person is not quoting 62 off head. The person is quoting it from a research that the person did. Do you understand? So, the moment we have a research gap and we have mapped out the steps that we need to follow for us to conduct this research, very key aspect of every research of this nature is what? Data. And because of that, the person will now begin to talk of how do I generate my data? What are the things do I need to do in order for me to obtain the data that I need? Because it is the data, when it is well obtained, the way it should be obtained, that will be subjected to analysis. And the moment it is well analyzed, we'll be able to come up with what? With a good result. I want to say at this moment that the type of data that one has collected for his research goes a long way to determining whether the research output is going to be good or not. Is that clear? If someone has gone to obtain a wrong data cannot give a good research finding. It's not possible. No matter how wonderful you may think that the research finding is, it is what? Error. Why? Because the data upon which the finding is based, the data itself is erroneous. Therefore, that finding must be what? Erroneous. So, we discuss data. Generally, data may be defined as a set of information obtained for the purpose of knowing more about a system. A set of information obtained for the purpose of knowing more about a system. Good. In statistics, the word data refers to a collection of numerical information obtained from all or some units of the system for the purpose of studying the system. When I'm talking about studying the system, I'm sure we understand what you are talking about. That particular subject of your research, the study, for you to study it, you need the data set. And what is data? We have given it, first of all, to mean as what? A set of information. Is that clear? But when we say a set of information, for us in statistics, it is not a definition of data. Because information, we understand with the elementary knowledge of our computer science that information can be numeric and or what? Or alphanumeric. Is it not so? Information can be numeric, it can be alphabetical, it can be alphanumeric. For instance, if somebody decides to gather the names of everybody here in this hall for this workshop, the person has the information. Is it not so? Is it true? But such information to us in statistics, we cannot regard such information as what? As data. Is that clear? What then makes data? We have said that the word data refers to a collection of numerical information. So for us, data must be numeric for it to be able to what? To be known as data in statistics. Data cannot be alphabetic. It cannot be alphanumeric. It must be numeric for us to be able to make use of it, because it is only numeric data that can be analyzed to us. For those in linguistics, for instance, they can analyze alphabetic data. For instance, someone who is interested in looking at a phrase, he is interested in finding maybe the frequency of use of maybe what the articles. We know in English language there are words that are called articles. Is it true? Maybe definite or indefinite articles, A and D. Some A and what D. Somebody is interested in looking at the frequency of the usage of articles by maybe undergraduate students. As a linguistic, what the person will do is to correct, maybe give those students an essay to write. Is it not so? And when they have written an essay, the person collects it and the person is looking at what? Looking at those articles. To such a person, he has collected data. The moment the assignments have been pulled to him, he has what? Data. To such a person. But to me, as a statistician, is not what? Data. Why? Because it is still alphabetic. For it to mean data to me, it must be converted to what? Numeric. So that I will see it as what? Data. So they are obtained as realizations of values of the characteristics of the system, known as variables. Every single subject of study has variables, has characteristics. Is that true? Every single subject of study has characteristics. Is that clear? So, when one begins to collect information from those things that characterize the subjects, then the person has what? Data. And those characteristics are known as what? Variables. For instance, borrowing the example that the person that bailed me the other time gave, talking about elderly people, maybe studying the elderly people, especially as it concerns what are those two sicknesses? Diabetes and hypertension. Good. One is looking at the connectedness between diabetes and hypertension amongst the what? The elderly. So, in such a situation, there are things that characterize the elderly. And one major and the most significant characteristic of every elderly is what? The age. It is the age that marks someone elderly. Is it not so? So, that is the most important characteristic of the elderly. I hope it's clear. So, to anyone that is embarking on such a study, age has become a variable because it is a characteristic of the subject under what? Study. Is that clear? So, age is a variable and so many other ones. There are so many other variables like gender and so on and so forth. Is that clear? So, what is a variable? Put better, I say the variable is a characteristic of a system which varies from one unit of the system to another. Any characteristic of that particular system or any characteristic of the subjects under study that varies from one individual to the other is what? Is a variable. Like when we are studying the elderly, we have said that age is a variable. Why is it a variable? It's a variable because it changes as we move from one elderly person to the other. All the elderlies don't have the same age value. Is it true? So age is what? A variable. Why? Because number one, it is a characteristic of the what? The subjects under study. And the two, because there is a characteristic, but it's what? It varies. So when we have it, we say that we have a variable. So every single thing that we know as data, they don't come from anywhere. They are values that are obtained from where? From variables. Anything that you call data is a value that is obtained from a variable of the subjects under study. Is that clear? I hope it's understood. Okay. A scientific study of a system, therefore, may be regarded as a study of the behavior and interrelatedness of the variables characterizing the system. So when one is conducting a scientific research about a particular system, there's no other thing that one is trying to do other than looking at what? The interrelatedness of those variables that characterize those individuals. I don't know if it's understood. For instance, still using that example, we are studying the behavior or the link or the connectedness between hypertension and diabetes amongst the elderly. We begin to look at what? Several variables that characterize the elderly. Is that clear? When we have known them, those variables, I want to give some of them, even though as a layman, it is possible. Age, I have mentioned, is one variable. Is that clear? Number two, maybe gender will be a variable. It is equally possible that maybe blood group may be a variable. Is that clear? Maybe genotype will be another variable. So when we go into study, we are studying the elderly and the connectedness between diabetes and so on. And again, maybe because when we are looking at them, we may be looking at those that are suffering from diabetes and hypertension or things like that. Do you understand? So there's no other thing we'll be studying there apart from looking at those characteristics and seeing how they are interconnected, their interrelatedness, how they are related. Is it possible that someone, for instance, who is above this certain age, who has diabetes, that there is likelihood that the person will be what? Will be hypertensive or things like that. I don't know if it's understood. At the end of the day, that's the kind of findings that one will be coming up with. Is that clear? So the research there is no other thing than looking at the interrelatedness of those variables that characterize that particular system. So when one is doing that, the person is conducting research in that regard. There's an example that is here, but I have used another example, so I will skip this one. I said these and many more are the variables that characterize the study. So let's leave that. So in this regard, the needed data for the study shall be formed by the values of these variables. Like the example we have given, by the time we are gathering values from these variables, age, gender, blood group, genotype, and so on and so forth, maybe whether the person is diabetic or not, and so on and so forth. And even if it is possible, if those sicknesses have degrees, one may equally be interested in looking at the degrees of those sicknesses. I'm sure you understand what I mean by that. There are some that are chronic, while there are some that are mild. Is that clear? So as one is getting information about all of them, at the end of the day, the person has obtained data for analysis, and all of them have formed the variables that are going to be studied in this particular research work. So, looking at variables, we now talk about types of variables. There are two types of variables that we make use of in statistics and in research. They are qualitative variable and the quantitative variable. And what is a qualitative variable? A qualitative variable is a variable that takes non-numerical values. Is that clear? From the example that we have picked as our case study, gender, for instance, is a qualitative variable because it doesn't have numeric values. Is it so? All right. So the next is quantitative variable. And what is a quantitative variable? A quantitative variable is a variable that takes numerical values as they are measured values of observations. So when one has that, the person has what? A quantitative variable. Still using the example, our case study, age, for instance, is a quantitative variable. Is it true? Because ages of elderly persons, we know them to be what? Values, numerical values. Maybe someone is 72, someone is 78, another person is 92, and so on and so forth. And again, it equally goes beyond the maybe age in years. Depending on the study and the nature of the study, age can go beyond years. I'm sure we know that. Do we understand what I mean? There's a particular type of study you will be you will be conducting, that you are no more talking of age as in years. Age may be in days, it may be in weeks, it may be in months, it may equally be in years. I'm sure it's clear. All right. But whatever may be unit of its measurement, it is always what? Numerical. And because it's numerical, it is quantitative. Now, having taken that, when we talk of quantitative variables, there are equally two different types of quantitative variables. Number one is the discrete variables. Every discrete variable is quantitative, but we have discrete quantitative variable. And what is a discrete quantitative variable? It is a variable or a quantitative variable that takes only what? Integral values. Any quantitative value that takes variable that takes integral values. We know what we mean by integral values. Yes, that takes only whole numbers. Such a variable is a discrete variable. For instance, if one is interested in looking at maybe the number of persons suffering from a particular ailment, what the person will be looking at is what? Number. Is it not so? Maybe it is possible that this study has been partitioned according to any other variable. Maybe it may be according to genotype. This particular genotype, we have 20 of them. This other genotype, 32 of them. This genotype, 7 of them. I'm sure we understand that. And this other one, 0 of them. I'm sure that we know that 0 is a value. Okay. So, because it is not possible to have 7.2 patients, it is not what? It is not, it is quantitative, but it is discrete. Is that clear? I said because it is not possible to have 7.2 patients. Because it is not possible to have 7.2 patients. Is it possible? Maybe people go to the hospital more than myself. Maybe you may have known that one can have 7.2 patients. But if you know it's not possible, then what we are saying is that the number of patients is what? Discrete. Is discrete. So the next is continuous. Any quantitative variable that can take integral values is that can take real values is known as what? This continuous variable. Example of them is age. Because when we are talking of the elderly persons, and we are looking at their age, someone may be tempted to begin to give age to be maybe 92, 71, 60 this, and so on. Is that clear? But I am sure none of us here has, I am almost sure, let me use that word, almost sure, that none of us here has a discrete age. None of us here has a discrete age. It's not only birthday. Today may be your birthday, but were you born by this time? The year you were born. Were you born by 3:32 p.m. that day you were born? So long as you were not born exactly the same time you were born, that means your age is not discrete. Do you understand? Assuming somebody will ask you, what is your age? You say, I'm 35. For instance, are you really 35? No, you are not. You have only approximated it to the nearest whole number. That's what you have done. And oftentimes, we don't even approximate to the nearest whole number. More oftentimes, we use last birthday. Because someone that was born, for instance, sometimes we not only last birthday. Someone that was born in in June, the year the person was born, Maybe that person is 10 years today. Maybe the person will be 10 years in June. You ask the person his age, the person may say, I'm 9. Do you know why? Because the person has not cut the cake for the 10th year, but the 10th birthday. So that person is still 9. Not mind the fact that June is just next month. If it is going to be by approximation, that person is actually what? 10. So that is to say that age is a continuous variable. We should be giving our age values by saying maybe I am 31.25 years. If someone says that that person is not wrong, that person is correct. Okay. So we look at this little diagram where we have variable. We have noted it to be a characteristic of a unit or population or a system that has the capacity to change as you move from one to the other. And because it is variable, we have said that it has two types, qualitative and quantitative. And the quantitative has two types, discrete and continuous. So we look at another types of variables. We have yet another categorization of variables apart from being discrete or continuous, apart from being qualitative or quantitative. We have another categorization, and that categorization is what we have come to look at. Number one is response variables or study variables. Every variable is not a response variable. Every variable is not a study variable. We need to, for us to understand this, I said, these are variables that are under study. For instance, in a study to determine the rate of typhoid fever among pregnant women in a locality, the number of such cases observed is the value of the study variable. Is that clear? Do you get that? What we have called the study variable, response variable, or target variable. The variable that you are studying is the response variable. It is the variable that you will be looking out for its responses so that you will put it down when you go to the field to collect data. And when we are doing that, or when we have such, we say that we have what? Response variables. Maybe we'll understand it better as I go through the rest. So, we said that the next type of variable or variables are what? Grouping variables. And what are grouping variables? We said this is the type of variable that is used in research to categorize respondents or responses. To categorize respondents or responses. We have an example here. I said, if in that example we gave before, the rate of typhoid fever case, that one's interest is to determine the rate according to the age of pregnancy. The rate of typhoid fever amongst pregnant women, okay? But our interest is to know this rate according to what? The age of the pregnancy. I'm sure we understand what we mean by that. Maybe we know that the full age of pregnancy is what? 9 months. But there are different stages, different levels, and that's what I mean by ages. It may be what lay people like me know that they call what? The trimester. Is it not so? The first, the second, and the third. Somebody may group all the pregnant women in locality according to the what? The trimester. And when it is grouped, one is now looking at what? The rate of typhoid fever amongst pregnant women according to their what? Their trimester. Is that clear? To the extent that the results of the rate that one will be obtaining from the first trimester often see this one happens most often when maybe 2 or 3 students are working under the same supervisor. Okay? And the supervisor has a project, a research project he is embarking upon. And for him to conclude this research project, which may span maybe over a period of like 5 years, he may decide to recruit up to 3 to 4 PhD students in this same project. Does it now mean that 3 of them or 4 of them are going to write the same thesis? No. They are not writing the same thesis. But 3 of them are studying the same thing. But they have their different words, interests they are looking at. The person that has the project knows that if we're able to get this interest from student A, interest from student B, interest from student C, and pull them together, that will amount to doing what? Accomplishing the project. Do you understand? But these 3 different interests will be able to give 3 different persons different PhD program theses. Is that clear? So 3 of them are working together. They are doing everything together, speaking the same language. Do you understand what I mean by the same language? Because all the things, variables, everything they will be speaking is just the same thing. Do you understand? But there are 3 of them are looking at this same thing from 3 different perspectives. And at the end of the day, this person will complete his own, this other one completes his own, the third one completes, and they put them together. And it becomes the accomplishment of the project. Meanwhile, those 3 theses are different, but they are speaking the same language, talking about almost the same thing. And that is why if somebody maybe looks at it on the surface, that person may think, what are these people doing? They are doing the same thing. But is it actually the same thing they are doing? They are not doing the same thing. Even though they will be talking the same thing, speaking the same, if there are some dictionary in the dictionary of that particular field, there are languages that needs to be spoken. 3 of them are speaking the same language. Do you understand? But they are getting different results according to the interest that they have. So when that happens, we have noted that statistical data are collected as measurements obtained from the variables of interest. Whatever is the variable of your interest, you collect data, this person collects, another person collects, and that makes what? What you now need is that if you're able to collect your own data, careful analysis of it will produce your own result. Another person does his own, the other person does his own, and the work is going on. So, having said that, the next we are going to look at is the scales of measurement. Because whenever we have outlined the variables that we are interested in, variables themselves, they don't speak. Do you understand? The only thing that can speak for us in our research will be what? The information that we are doing what? We are deriving from the variables. Is that clear? So it is important we now look at the scales of measurement so that we'll be able to know what we are measuring from those variables. And that is what we have come to look at, the scales of measurement. So here we shall discuss data in the light of the fact that they are obtained as measurements of variables. Now, it's important that we note, and this is going to be very important to us because of the question I had asked us, if trimester is, whether it is qualitative or quantitative data. Well, we see that as we discuss these scales of measurement. So, there are 4 scales of measurement that we know, and we will say that we are getting data. There are 4 scales of measurement. Number 1 scale of measurement is the nominal scale. Number 2 is the ordinal scale. Number 3 is the interval scale. And number 4, which is the highest scale, is the ratio scale. So 4 of them make up any single thing that you know as measurement, numerical measurement, come from either of these 4. The Besides them, there is no other scale of measurement. We will start with the smallest one, the nominal scale of measurement. And what is the nominal scale of measurement? Nominal scale, categorical data and the numbers that are simply used to identify a name or attribute of a variable represent a nominal scale of measurement. We will give an example. Examples include, maybe in your study you have a variable called gender. Is that clear? And you know that there are two values, two possible values of gender, male and what? Female. I may decide to say, in this my study, let one be what? Males. And two, females. Again, somebody else that is studying maybe year may decide, let less than 20 years be what? One. So for him or to him, anywhere he sees value of year to be one, he has already known it to be what? Less than 20 years. Is that clear? For you, to you, if you look at it, you may not understand what one means. Does it mean somebody says year and they put answer equal to what? One. And you'll be wondering, does it mean that these respondents, that this particular respondent is 1 year old? Does it mean that? And maybe, for instance, if it is something that has to do with maybe pregnancy, you will now begin to ask yourself a question. What do you mean by this? Do you mean that a 1 year old person can be pregnant? Not knowing that it is actually not what? An actual value, but what? A value that has been given to represent a group. So, 1 is less than 20 years, 2 is between 20 and 50 years, and 3 for more than 50 years. Again, somebody may say, let 1 be for broad group A, 2, broad group B, 3, AB, and 4, O. It is only known to that person and to whoever that person discloses the key. Is that clear? If it's not disclosed to you, you may not know. And let's look at it from this way. In the case of gender, 1 for male and 2 for females. Under normal circumstance, in real life as we know, 2 is greater than 1. Is it true? Anything you see 2 and 1, according to quantification, 2 is higher than what? 1. But in this case now, in this study, 2 is female, 1 is male. Is female greater than male? Huh? What if it is put the other way around? Is male more than female? None of them is more than each other. So, when we are discussing this first scale of measurement, which is the nominal scale of measurement, all the measures that we know, arithmetic measures like plus, they cannot be added because 1 plus 2 is equal to what? 3. So, if I have a male and a female, when I add the two of them together, is it equal to something that is not defined? It is not equal to something that is defined. Is it not so? Because we have noted that in this our definition, we have only 2 possible values. 1 and what? 2. Anytime we say 3, it means what? An undefined answer. Is it not so? 1 plus 2 is equal to 3. But 3 is not represented. And again, if we come to the broad group, 1 is A, broad group A. 2 is broad group B. 1 and 3 is broad group AB. A, broad group A plus broad group A and B. Is it equal to broad group AB? Is it equal to that? Good. But in this case, 1 plus 2 is 3, which now takes us to what? Broad group AB. I'm sure we understand what we are saying. So we cannot do subtraction, we cannot do addition, we cannot do multiplication, we cannot do division. They are just there as what? representatives, as something that has been used to do what? To label. They are simply labels that have been placed on values. Is that understood? And because they are labels, they are not amenable to any algebraic or mathematical calculation. They are not permitted for any such. So that is the nominal scale of measurements. Oftentimes in our research, we use nominal scale of measurement. When we go to the field, we are looking at maybe gender, we are looking at highest educational qualification, we are looking at so many other, which other ones? We will have a list of them. And maybe when we want to carry out the analysis, because I have said that in statistics we don't understand any other thing except what? Numeric values. We will need to convert them to numerical. And when we have converted them, 1, 2, 3, and so on, those ones, they are just labels that have been placed there. And there's no other thing that can be they can be used for. And that is why they are called nominal scales of what? Measurements. Number 2 is the ordinal scale. And a scale of measurement in which values of the variable of interest represent categories that differ quantitatively in terms of their order. In ordinal scale of measurement, it is almost the same thing with the nominal scale, with only one little addition. And what is that addition? There is what? Order. That is the only addition that it has to the nominal scale. Why in nominal scale there is no order? 2 is not greater than 1. 3 is not greater than 1. And by the way, it is someone that is conducting the research that decided to give them 1 and 2. Another person may decide to give them 0 and 1. Another person may decide to give them 0 and 100. Another person may decide to give them 1002. Do you understand? Whatever thing you call it, it is just a label to it. So in this ordinal scale, the only addition is that there is what? Order. One will be able to know that this one is higher than this one, and that this one is higher than this one. The only thing that one will not be able to know is to what extent is this one higher than this? To what extent is this one higher than this? Do you understand? For instance, one may be conducting a research, especially, okay, let me give the example that is here so that I don't jump this one. Okay, the example that is here in a research to determine level of satisfaction of patients with a particular treatment that is given to them in a hospital. You want to get a feedback from the patients, how satisfied they are. Do you understand? In a hospital. Then there may be values like 1, 2, 3, and 4 for not satisfied, fairly satisfied, satisfied, and very much satisfied. What it means is that 1 stands for what? Not satisfied. 2 stands for what? Fairly satisfied. 3 stands for what? Satisfied. And the 4 stands for what? Very much satisfied. Sorry, what here is very, but it should be very. This thing should be E, V-E-R-Y. Is that clear? So in that case, because our interest is on the level of satisfaction, very much satisfied is the highest. Is it not so? While not satisfied is the least. Is it not so? Again, fairly satisfied is less than satisfied. While less than satisfied is less than very much satisfied. Do you understand? So there is, in such a situation, there is what? Order. Levels of satisfaction, there is order. So one will be able to know the order. But knowing the order is just the only addition that it has to the nominal scale. The reason is because they cannot be added. They cannot be subtracted. For instance, in this example, 4 minus 1 is what? No. In real life, 4 minus 1 is what? 3. Is it not so? In this case, 4 is what? Very much satisfied. 1 is what? Not satisfied. Very much satisfied minus not satisfied Is it equal to satisfied? It's not equal to satisfied. They cannot be subtracted. They cannot be added. They cannot be multiplied. They cannot be divided. They are just representing situations or categories, but there is what? An order in the arrangement. Is that clear? So that is the only difference between it and the nominal scale of measurements. The next one is the interval scale of measurements. In interval scale of measurements, the exact differences between the values are known. In interval scale of measurement, the very exact differences between the values are known in addition to knowing the order. So, in interval scale of measurement, there is one thing that has been added on top of what we have known about the other two. And what is it that has been added? That we now know the what? Exact differences between them. So if measurements have the capacity of producing exact differences, it means that they can be added. They can be what? Subtracted. Because the differences are what? Are known. Is that clear? So that is about interval scale of measurement. And I said this scale has no true zero. But zero is simply an additional point of measurement. In real life mathematics, zero is what we know as a state of nullity. Is it not so? Nothingness is what? Zero. But in this case, zero is another value. It is not a state of nothingness. Do you understand? It's yet another value. I have an example here. I said an example for this is when we have temperature measurements in degrees Celsius. We know that a measurement can be 10 degrees Celsius. Is it not so? Good. And I said 10 degrees Celsius minus 10 degrees Celsius is equal to what? 0 degrees Celsius. Now, 0 degrees Celsius does not mean no temperature. Does it mean so? It doesn't mean no temperature. But what does it mean? It means what? Another temperature value. When temperature has a 0 degrees Celsius, it is what? A temperature value. It doesn't mean nothingness. Is that understood? So in such a situation, temperature measurement in degrees Celsius is what? An interval scale of measurement. We know the actual difference between any two of them. 100 degrees minus 20 degrees is equal to what? 80 degrees. Is it not so? And it is yet another value. Now we look at it again. Also, 10 degrees Celsius plus 10 degrees Celsius is equal to what? 20 degrees Celsius. But there is a problem. Yet, 20 degrees Celsius is twice as hot. It's not twice as hot as 10 degrees Celsius. Is it true? Is it true? One cannot say, because this condition is at 10 degrees Celsius. This condition is at 20 degrees Celsius. Therefore, it means that this one is what? 2 times double the hotness of this one. It doesn't mean so. They are just what? Different values. Do you understand that? So, in this scale, multiplication and division is not possible or are not possible, but addition and subtraction is possible. In interval scale of measurement, multiplication and division, they are not possible. We don't divide them. Because of the obvious reason, what I have said, you don't divide them. Because if you divide, what you are getting, you don't multiply them. If you multiply, it doesn't mean the true state of things. Because if I say 2 times 40 degrees is equal to what? 80 degrees Celsius. Can anybody survive under 80 degrees Celsius? I don't know if it is possible for someone to survive under 80 degrees. I don't know. You should know better than myself. But what I'm trying to say is that maybe multiplication is not possible, division is not possible in interval scale of measurement, but we can know differences amongst themselves. Is that clear? Division is subtraction is possible and addition is possible. The last scale of measurement is the ratio scale of measurements. And this is the height of every single measure. The height of every value that we see is the ratio scale. It says that it has a true value. As a result, both addition, subtraction, multiplication, and division are possible in ratio scale of measurement. There's an example of a ratio scale of measurement, and that example is the height in meters. 10 meters plus 10 meters is equal to what? 20 meters. Both in the actual sense and in the calculation. Is that clear? If we have 10 meters distance, you get another 10 meters distance somewhere. If you join two of them, you have covered what? 20 meters. Again, 20 meters is twice 10 meters. 2 times 10 meters is equal to what? 20 meters, and it is true in real life. Also, 0 meter simply means what? No height value is a state of nothingness. So when we have this scale of measurement, we call it what? The ratio scale of measurement. So, a minute before we will know if we are continuing or not. Because I said it. If I want to, I will stop. But the question is, can we start early tomorrow? As early as. Okay, the online people. Will they be able to? Okay, these people, if they'll be able to come. They are students now. Ah, yeah. I don't know your students. If you tell them to come, they will come. So 9 o'clock is okay. All right. Okay. Before I say the next thing, let me ask for questions, which I'm sure there shouldn't be any question. But if there is anyone, we can take one. Any question? No question. Yes. Ask your question. Mm-hmm.
Can we say that Likert scale is under this?
Yes.
Okay.
Likert scale is an ordinal scale of measurement. Okay. Having another question? Do you have a question? Okay. So this.
We appreciate the presentation of the lesson. My question is, you said that statisticians consider only numerical data. They don't go with non-numerical data. But so is it that they don't carry out qualitative data or what? Because qualitative ones borders on non-numerical data. So do you only want to conduct qualification?
Okay. Thank you for the question. I think it's a very important question that he has asked, because we have two aspects of research. We have quantitative research and we have qualitative research. And it is important that we look at two of them. And we know what the qualitative research is all about. For instance, if somebody maybe decides to conduct interviews, okay, and get information from different people on a particular issue, and at the end, based on the information he has got, he will be able to report what he has seen from those information. That is a qualitative research, where quantitative is a case where we have numerical information that are subjected to statistical analysis. And having said that, I want to say that qualitative research is not a statistical research. In answer to your question, okay? But it is a scientific research. Every scientific research is not statistical. So qualitative research is a scientific research, but it is not a statistical research. Do you understand? So it is a well and highly recommended research. The only thing is that it doesn't have any aspect of statistics in it. Do you understand it now? But it is purely scientific, and one can use it to come up with a finding that is very interesting. Now you have another question, a follow-up question.
Yes. But why is it that quantitative research still employ statistical tools like I-squares? Because we use it in carrying out.
Okay, yes, I will still come to that. At this point, it is important. Do you understand? So the aspect you have brought in is a case of a mixed research. Do you understand what I'm saying? There's nothing chi-square test, for instance. it is expected that we have covered half of the workshop. Is it not so? Because it is a 2-day workshop. But that is the expectation. But in reality, we have not covered up to half. And we cannot extend it beyond tomorrow. And what it means is that we will need to be on time tomorrow, so that we will be able to cover even the time that we lost today. So that by the time we'll be rising tomorrow, we will be sure that we have covered everything that we need to cover. And I have discussed with the faculty rep, and we have agreed to start, that I should start speaking tomorrow by 9 o'clock in the morning. 9 a.m. tomorrow we will start. Thank you and see you tomorrow.